So anyway, we're starting here at 1 o'clock. Josh Magri with Hacking Azure Services for Bounties and Credentials. Josh is a security consultant at NetSPI, where his main focus is Azure testing, includes contributing to the MicroBurst project, which is a collection of offensive security scripts for Azure. He's doing research and developing new tools and techniques for attacking Azure services. He got started with the Azure stuff with a course from BHIS. Was that Bo's class?
Yes.
Bo Bullock's class. BHIS, that's now all the anti-siphon stuff. We've moved over, but old school BHIS, right? And has since authored several tools and blog posts about Azure pen testing. He's previously worked as a pen tester, red teamer, and an application security consultant, holds the GSEC, GCIH, GCFA, and OSCP certifications. Josh, thanks for being here. All to you.
Thank you. Yeah, hey everybody. So this is Hacking Azure Services for Bounties and Credentials. I submitted that bio a while ago, so I actually work at IBM now. I'm on the red team at IBM. IBM's my first red. I was previously at NetSPI, where my focus was Azure pen testing. So basically everything in this talk is from there. There's a few new additions, but the majority of the content is from my time at NetSPI. You can find me on Twitter at @PassTheHashBrown or GitHub, same username with more characters. A little bit about me. I got a puppy about 3 months ago, a little beagle mix, drives me crazy. And I rode my bike across Iowa last summer. Looking forward to doing it again this year. It gets me away from the computer for a bit. So quick agenda for today. First, we're going to define our goals and cover some Azure basics. We're going to walk through an exploit I found in Azure Logic Apps, an exploit I found in Azure Automation, and then a few other minor techniques. These are things that they're not ODAs or anything. They're kind of things I found throughout the years that I've been doing Azure research, and weren't big enough for a blog post, but I thought I could get them all in here. So first up, why Azure? Cloud's sort of the cool new thing, right? Everybody's getting up in there. The big three, Azure, AWS, and GCP. And Azure AD is a really popular offering. So even companies that aren't using Azure for infrastructure as a service, they may still be using Azure AD. So a little bit of Azure knowledge can get you a really long way on an engagement. And cloud's a really interesting target because there's a lot of really weird things happening at scale, and a lot of that is abstracted away from the user by design. So sometimes you find things that the developers didn't intend for you to see, and you can kind of pull that thread a lot. And in the event that you do compromise a service or something similar to that, the impact is severe and immediate. So when you find a bug in like on-prem AD, it's not necessarily, you sometimes you'd be inside the environment first, so there's a prerequisite. But in Azure, you compromise a service, you've compromised everybody using that service. I stole this picture from Andy Robbins at Waldo on Twitter. He gave a talk earlier today, and he did a Twitter thread about this a little while ago. And Azure is still relatively young. I got into pen testing in, I think, 2016, 2017. So Active Directories are even exposed to a lot of scrutiny. You know, it's like 20 years of scrutiny. What am I going to find in Azure, or in Active Directory? But Azure is not quite the same. We still have a lot of time before we get up against that same timeline as Azure. Sorry, as on-prem AD. And there's a lot more bugs to find, as we're going to talk about. So some recent Azure exploits. This is not a comprehensive list, but just some of the highlights. Chaos DB was a compromise of the Cosmos DB service. Oh my God, you could get RCE on Azure Linux VMs by default. And Extra Replica, this one was like a week ago, I think, was a service compromise of PostgreSQL. And all three of these were from the team over at Wiz, a crazy smart team over there. Auto Warp, you were able to get cross-tenant managed identity tokens from Azure Automation, which was like one of the worst bugs you could possibly find. And Cred Manifest, this was found by my colleague at NetSPI, Carl Fossen. If you know Azure, you probably know Carl. And he found that they were leaking clear text credentials for automation accounts in Azure AD. So any reader in Azure AD could potentially get these certificates and authenticate to subscriptions. And this is sort of how I felt. I've been working on this talk for a little while now, and I've been watching all these people release these really awesome exploits and getting paid tons of money in bounties. And I'm over here with my two little exploits, polishing them. But I like them, so hopefully you will too. So before we get into that, there's two kinds of Azure bugs. So there's exploits and there's abuses, and this applies to everything in security really. But so there's an exploit where it represents a flaw on behalf of the cloud provider. So this is something they messed up, and it gets fixed when it gets discovered. So Auto Warp, Chaos DB, these things we just talked about, these are all exploits because they got fixed immediately, and it was a flaw on behalf of the provider. This wasn't by design. But an abuse, it's usually a feature. We like to abuse features, right? The features, it's a bug. And it doesn't warrant a fix. So for example, everything in get AZ passwords, which is part of the MicroBurst project, that's mostly abusing features. So dumping credentials from automation accounts, if you have the proper rights to do it, you're allowed to do it. You can do it. So really quickly, go over some basics in Azure, just so we're all on the same page, some of this terminology. So in Azure, we're going to be talking about Azure Resource Manager. This is like infrastructure as a service, platform as a service. There's the root tenant. This is the highest level in Azure. Then in the root tenant, you have management groups. Under the management groups, you can have subscriptions, and billing happens at the subscription level. So this is generally where things are logically grouped. Then in a subscription, you have resource groups, and in resource groups, you have resources, and that's the final. A virtual machine is a resource, a database is a resource. We have a few roles in Azure. The highest role is owner. So owners have full control over resources. You can assign roles, you can change and delete resources. Contributors, you can make changes to resources, make new resources. You can't assign roles on them though. And then finally, reader, you can read information. You can't read passwords or keys though. We're gonna talk about why that's not always true. And user access administrator is kind of a weird one. So user access administrators can give themselves roles. So functionally, you're an owner. If you have user access administrator, you can just give yourself owner. Sorry. And these roles can be assigned to any of those scopes we talked about. So you can have a subscription owner, you can have a management group contributor. You can mix and match those however you want. And then to make it more complicated, you can assign roles specific to services. So you can have a virtual machine contributor in a subscription. You can have an app services reader in a management group, that sort of thing. So you mix and match these, and that's sort of where this talk came from. You get in these really weird situations where you have this really weird role with like a few actions, and you need to figure out, how can we break out of this? What can we do? So first up, we're going to talk about Azure Logic Apps. Logic Apps are a low, no-code service. If you haven't heard this before, it's kind of it's like a tool that enables non-technical users to create powerful workflows, like a drop and drag GUI. So an example would be whenever an inbox gets an email, parse the subject line, and if it says hello, we return world. And you could drop and drag, when email, compare text, do this thing. And an important question to ask whenever we're working with any service in Azure is, how is this service authenticating to other resources? So in the example above, how is the Logic app authenticating to that email inbox? And the answer is API connections. So an API connection is just a Swagger API definition, and we can actually create our own. We're going to look at doing one of these later. And the official ones with like the nice pretty pictures and all that, those are just ones that have been submitted to Microsoft for review, or they were written by Microsoft. So like AWS has one, they wrote their own, they submitted it to Microsoft, and then it got approved. So you can actually fetch the Swagger definition. It's kind of hard to see here. This should be blown up in a later slide, but we can make a request to the REST API, and it spits out all the paths and all the actions. So you have a get, put, delete, and these all correspond to different Logic app actions. So before we talk about the exploit, we're going to talk about API connection abuse. I wrote a blog about this a while ago. You can find it on the NetSPI blog. So when you create an API connection, you authenticate it, and that you just sign in, and then it associates that connection with your user. And you create a connection when you want to create an action. So for example, you want to create a key vault action. You want to encrypt some value with a value in your key vault. So you make the action. It says, okay, you need to make this connector. You authenticate. And the problem here is that you make this action, you make this connector for one action, but you can use all of the other actions in a connector if you have access to it. So for example, if an attacker has access to this API connection, but they don't have access to the key vault, so it's in another resource group, another subscription, they can use this API connection. They can use the list secret, get secret action to dump out the key vault. And there's a ton of weird interactions. Every connector is different. So for example, another one is like you can dump out SharePoint files for another user. And we consider this an abuse. The issue lies in the role assignments. No like crazy exploit going on here. It's not going to get fixed or anything. Some other considerations for Logic apps. Sometimes you find plain text credentials in them. For example, this is the HTTP action. You can see there's basic, client cert, OAuth, raw, managed identity. And if you find these, sometimes there's like service principal creds in here, and this is a pretty quick win for readers. And then also sometimes secrets get leaked in the history tab. And again, you only need reader access, but for a key vault action, see get secret here, test secret value, and you only need reader rights to do this, and it doesn't get leaked until runtime. And there is a setting so that you can obfuscate this, but it's not turned on by default for some reason. This is something I want to talk about, not the exploit, but a funny little thing I found. I reported it to Microsoft. They said not a vulnerability, but I thought people might find it interesting. There's an execute JavaScript code action. And when you hear like execute code in the cloud, it's like, oh crap, what can we do with that? So the docs say that we're running in Node, and there's a blog from NetSPI, funnily enough, about breaking out of Node sandboxes. And I tried to reproduce it for this talk. I wasn't able to. I don't have the screenshots anymore, so you're gonna have to take my word for it. But the sandbox is using VM2, and I started looking for sandbox escapes. I found this blog. I put the link there, and I took this command from there, and you can see we can read the directories on the file system. And I was able to escalate this to RCE at the time. I couldn't get the payload working, like I said, but you could get RCE from this. And this also works with XSLT via the transform XML action. And Microsoft said it's not a bug because you land in a function app. So it's a sandbox environment, really no harm done, but it's a cool thing. I got to look at some of Microsoft's code that they maybe didn't want people to see. So that's kind of funny. And one more bug in logic apps, you can get SSRF by making your own custom connector. You can point these at localhost. You're not supposed to be able to. You can see here that there's an error, says you can't point it at localhost, but this is just a front end restriction, classic, right? So copy post request from the browser, go into PowerShell, swap out ibm.com for localhost. And then you can see there's 200 response at the bottom there. And if we then run this, we run a logic app with this connector, we get a 404 for localhost. So I was like, oh, okay, I won't get anything here. But then if you make a request to like localhost 1234 or whatever, then you get a totally different response. You can see it resolve localhost to 127.0.0.1. So this is an SSRF, but not a bug. You can't get to IMDS or internal services. So again, just thought sort of a cool thing, show it off here, but not a bug. And now the bug, the juicy stuff. So the scenario we were in is that we were in a client environment and they had an API connection for the Azure Resource Manager. And we were authenticated as a user access admin at the root level. So remember, root level is the highest, and user access administrator, you can assign yourself owner. So this is kind of the highest level you can have in Azure. And our goal was to abuse this as much as possible. In general, we want to get to owner on a subscription. It's kind of like getting DA on an internal pen test. It's kind of oversimplified, but it's like a really good tool to say, like, look, I got DA. This is serious. So we did some initial recon, looking at what actions were in this connector. We found this create or update a resource, and we thought, well, that sounds like a good starting place. Maybe we can create resources, something like that. And this is the same screenshot from earlier, but I've highlighted the action that we're looking at. So it's a request to subscription, resource groups, and then the provider. And every resource in Azure has like a short ID. And then you put that ID in for that resource, and then it's a put request. So some background around this is that this is basically just a wrapper around a wrapper. So we're making connections to the ARM API, or the REST API with the ARM API. And so you make a request to the server makes a request to this URL, which is the same as was on the previous slide, but just blown up. And if we want to create a role assignment, we can swap out that provider short resource ID for that resource, so the Microsoft authorization service. And we can create role assignments this way. You just need to give it the role ID and the principal ID. But you can only make them at the resource group level. This is by design. If you saw earlier, there's a resource group field, which is mandatory. So you're not supposed to be able to make resources at subscription level. But we can use a path traversal payload in the resource group field. And the reason this works is if we make it blank, we get an error because it says, well, no, there's no blank resource group. So this doesn't work. But with a path traversal payload, it validates against the Swagger definition. It says, okay, this is a valid Swagger endpoint. And then it passes that to the app, and the app requests that full path with the traversal payload, resolves, and now we get a request made to subscription ID, and then the rest of our thing. So the impact of this is we can make arbitrary resources at the subscription level in the context of the user, and you can also put a path traversal payload in the subscription field, and you can hit the root tenant if you want to. So this was all fine and good. We could make a role assignment at the subscription level. We made ourselves owner, client's happy. But I went to reproduce this in the environment and it worked. But then I noticed when you make the action, there's like a drop-down menu for subscriptions, and it started populating with subscriptions I didn't have access to. They're out of scope. So I was curious. A request is getting made to see these subscriptions I shouldn't see, but I haven't run a logic app, right? So what's going on? And like anything in Azure, fire up Burp. Burp is an amazing tool. You can find so much weird stuff that's not really it's not secret, but you're not really supposed to see it. It's abstracted away from you. And sometimes that leads to weird things like this. So a request is getting made to the dynamic invoke endpoint. on that API connection. And this is sort of an undocumented feature, but it makes everything so much easier because you don't need to like make a logic app, run the logic app, get the output. So you can see the top screenshot is the request that's getting made. It's that resource ID with dynamic invoke at the end. It has get method and the path is subscriptions, and then we get a list of subscriptions back. So anyway, we submitted this to Microsoft back in October last year. They fixed it in March. We disclosed in a blog post, and then their fix was to disallow path reversal payloads. I did look, it no longer works. The payload I used, I haven't validated how good the fix is. So if you want $10,000, maybe take a look. So next up, we're gonna talk about hybrid workers. So hybrid workers are part of Azure automation, and automation accounts in Azure, their primary function is to run runbooks, which are just small pieces of PowerShell or Python code. And normally we use them to, if you want to manage infrastructure, so you want to like create a VM and apply things to it, you can do this via automation. And by default, these run in a sandbox in Azure. And those sandboxes have processing caps. Like it's with all those DevOps pipelines, people were getting like free compute time mining crypto. Microsoft doesn't want us to do that. So the solution they gave us was we can run runbooks on our own virtual machines via hybrid workers. So there's two types of hybrid workers. There's user and system. User hybrid workers are for running runbooks like we just talked about. System are for things like update management, another part of automation. We're not going to talk about that. They just don't have the rights to do the things we're interested in. So some quick background about how automation accounts authenticate. So there's a few options. The first one, you can just stick clear text passwords in the runbook. You shouldn't do this, but people do it all the time. Next up, so the next three options are the supported options. Service principal credentials. Service principals are kind of like service accounts in on-prem AD. You can create a service principal. You put the credentials in the automation account. There's a designated credentials field where like readers can't view them. Run as accounts, basically the same thing. It creates a service principal and it stores the certificate, but it does it like automatically. You just get to push one button, which is kind of nice. And it has contributor access by default. And finally, manage identities. This is what Microsoft wants people to use and what people probably should be using. It eliminates the problem of hard-coded credentials, which is where so many Azure problems stem from. The token gets fetched at runtime. Sometimes you need a secret to do this, which is stored in environment variables. And then you make a request to the instance metadata service, like in AWS. So this is what Microsoft is pushing people towards. So creating a hybrid worker group is pretty easy, like everything in Azure, just a few button clicks. And then you can add the hybrid worker, you can add a virtual machine. So when you actually install it, it installs an extension on the virtual machine, which is the hybrid worker service.exe. Makes sense. Okay, and then when you run a runbook on that hybrid worker, it creates the orchestrator sandbox.exe process. And right away, we looked at the command line for this and we were like, well, that's a pretty big command line and there's a few interesting fields. So there's a job runtime data service URI, there's a sandbox account ID, and then there's a secret. Whenever you see a secret, we're like, okay, well, what can we do with this? So we looked in memory. I used Process Hacker for like quick triage. So you go into the memory tab, look at strings, and then you can search for like HTTPS, see what all you're connecting to. And the answer is it's this JRDS endpoint. The automation account has an ID, and then there's automation accounts account ID. And so to actually access this URL, you can do it just like we saw. You need a system assigned managed identity on the virtual machine, which gets created automatically if one doesn't already exist. You just get a token for that identity, and then you can make a request to that endpoint. So the request I'm making here is we're making a request to see if there's any new jobs for this sandbox. And we get back nothing because there's no new jobs. So we wanted to know what more we could do. So we started reverse engineering it. But by reverse engineering, I mean I just guessed and I hit the /certificates endpoint and got back all the certificates for the automation account. And if you just hit this endpoint, it gives you all the certificates back. Same thing works for credentials. You have to know the name of the credential, but by default, readers can see credentials. You can see the names, so this isn't really a barrier. And this is what it looks like in the decompiled binary. You can just drop this into NetSPI. This is probably the right way to do it instead of looking in Process Hacker, but just automation accounts, credentials. So we submitted this to Microsoft. We thought that this was like, okay, this is a privilege escalation from a user who has access to the virtual machine, like a VM contributor, and then they can escalate to a subscription contributor. We wrote it up, submitted it. They didn't think it warranted a fix, and they did add a warning to the documentation. So I think now it says warning, virtual machine contributors can pull creds. and we didn't think anything of it, went on, researched other stuff. And we saw this blog post from the AZSec blog, a really awesome blog if you're looking for some more Azure resources. And its thesis is that you can compromise a virtual machine if you've read access to a subscription, and then the admin will push a cert down, and you can use that cert to authenticate. But something that my takeaway from this was this automation account keys. I've been pen testing in Azure for a year. I'd never heard of this. I kind of thought I was going crazy. You only need reader access in Azure Automation to get these keys, and then you use these keys to add a hybrid worker. So we sort of had like a series of epiphanies where hybrid workers can read credentials and certificates from the automation account. You only need an automation account key to join a hybrid worker to an automation account. You only need reader access to get that key. So readers can join a hybrid worker and then read credentials and certificates. And that was all great in theory. To actually do this in practice, there is allegedly a hybrid worker PowerShell module. I can't get it to work for the life of me. So instead, we took some source code from Microsoft in this PowerShell DSC for Linux repo. They have a register.py script. And the bare minimum process is you generate a self-signed cert or use an existing one. You get some information about the VM, so like machine name, IP address, that sort of thing. Put all this into a JSON blob, encrypt it, and then you send the info to the agent SCC endpoint. And this is the same as the endpoint we saw earlier. You just swap out the subdomain. So we can dump creds just like we did earlier, just with one HTTP request. You just need to have that system assigned managed identity. And then if you have a run as account in use, this is a reader to contributor priv-esc, right? Because run as accounts have contributor by default. And managed identities are actually the fix for this. So if you're using managed identities, then it wasn't really a problem because you need that MSI secret to request credentials, and you could only get the MSI secret if a job was run on your endpoint. So if you weren't using hybrid workers, but you were using managed identities, then you were not at risk here. And this is just the polling flow for hybrid workers, like I just mentioned. So you assign a runbook to run, they poll this endpoint every 60 seconds. First one to get the job runs it. You hit this endpoint with the job ID, and then you get the MSI secret. So we reported this to Microsoft in December. They gave me a bounty on the 31st, so a nice little Christmas gift there. They applied a fix around the end of March. I don't know if that's the exact day. That's just when I checked it and saw it was fixed. And we disclosed in a blog in April. And I had to include this. One person in, I think, 2019 opened an issue on the Azure GitHub docs repo. And they said, hey, why does the reader have access to these automation account keys? The docs say they don't have access to credentials, right? And a Microsoft employee replied saying, no, they need to have access to those to view all resources. So this is just a good reminder. Sometimes Microsoft says something's okay. That's not always true. Sometimes you get $10,000 for proving them wrong. Really quickly, want to talk about cred manifest a little more. This was discovered by Carl Fossen at NetSPI. I just want to talk about this since I didn't find this, it was all him, but I was in the room for it, so I thought it was an interesting topic. When you create a service principal, like we talked about earlier, it gets registered with Azure AD, and that handles all the authentication. And all app registrations in Azure have a manifest, which is just a JSON file containing some info about it. And service principals get assigned credentials with certificates or passwords. And manifests for service principals, they have a key credentials entry if you use certificates with the public key. It's supposed to be the public key. But for a few months, they were pushing down private keys. So any user with reader access in Azure AD could pull this private key and then authenticate to the subscription as that service principal. And now for something completely different, we're kind of going to lightning round through a few of those techniques I talked about earlier, where they're not huge things, but just some neat tips and tricks that you might find useful. So first up, virtual machine extensions. I like talking about this because I found this before I was like an Azure guy. I was trying to do this thing. Jake Carnes published a blog a few years ago. When you run a custom script extension on an Azure VM, it stores the settings on the VM. And then if you have a local admin, you can dump those. And sometimes you can find secrets in those settings, pretty frequently, actually. And I wanted to do this across a whole host of VMs, but I didn't want to run it on all of them. I wanted to know, okay, where do we have custom script extensions so we can kind of triage this? And VM extensions have a public and a private settings field. So like I said, the secrets should go in the private settings field, but sometimes they go in the public settings field. I've seen this a lot with DSC, desired state configuration. A lot of storage account keys sometimes get pushed in there. You only need reader access to run this command. It'll dump out all the extensions, and then you can just grep through for secrets. Next up is policy definitions. So policies in Azure, you can use them to manage resources and make sure they conform to some standards. So you have a bunch of VMs, you want to say, okay, do these all have a certain patch for SQL Server installed? You can write a policy for that. And then if it doesn't have the correct patch, you can apply a remediation action. So go ahead and install it yourself. So sometimes credentials get leaked in the policy definitions or assignments. These are two really clunky commands. These will dump out just all the policy definitions, all the assignments, convert them into JSON, dump them. And again, you can grep through these for passwords. Function app file systems are function apps are Windows and Linux containers. They expose API functions that you can then call part of the app services service line. And there's a file system you can interact with. So like if you want to publish your code, you go and you publish it to an actual file system. Contributors can do this with the console tab, but readers only have access to the app files tab. And the output from this is not recursive. So you can see here, this is the app files tab. You click on this dropdown, it shows you hosts.json, supersecret.json. But if you make a request to the REST API manually, you see there's actually a folder, even more secrets, which just doesn't get displayed to us. And then you can make a second HTTP request to this folder, and you can see, okay, well, there's another super duper secret in there, which we want. So just a trick, sometimes you can get like DLLs or configuration files get stored in folders. And in Azure, we're just always looking for these weird little misconfigurations. Next up is service principal secrets. I found this a few months ago. I think I tweeted about it, but I never really talked about it or did anything with it. But basically, service principal secrets, when you generate them, they follow a certain format. So it's 5 letters and then a tilde character. I think a few months ago, this was actually different, but I can't remember for sure. But so it may change. But anyway, after generating them, you can see the first 3 characters of the passwords in that second screenshot and like the third column. It's the first 3 characters. And you can use these to hunt for passwords because you run your MicroBurst tooling, your PowerShare tooling, all that. You've dumped out all this stuff. Now you can grep for these 3 characters. And if you find them, then go ahead, grab 32 characters, the size of the secret. And you might actually be able to just automatically find service principal secrets. And you can automatically validate them too, which is really cool because we have this problem in Azure where it's hard to know when you found a credential without like a person hands on keyboard verifying it. But since you already know that you have this credential and you have the app ID for the service principal, you can use this snippet of PowerShell code to dump out all the credentials. And then you can run this connect AZ account, which is how you authenticate as a service principal. And if it works, then you know you found a valid credential. And this leads to some kind of cool possibilities. It's kind of fragile, you know, because automated credential discovery is always hard. But when we find and validate it, we can compare the permissions of our new user to our old user, the one we're currently in. And then if it has different privileges, we can just rerun the tooling to get the new resources. And you can do this ad nauseum, assuming you keep finding resources or keep finding credentials. And you can automatically pivot between different users and subscriptions. I wrote a kind of crappy proof of concept called AZ Autopwn a while ago, which you can see doing that. So we find a service principal credential in, I think it was a app in a automation account. And then there's one, a function app or something like that. And you can pivot between different subscriptions automatically. And really quickly, this is just a life hack for Azure. This is using the REST API, which kind of undergirds all of Azure. So anytime you're interacting with the PowerShell commandlets or the CLI, you're actually just using the REST API, but it's abstracted away. So you can find a lot of really weird stuff by just hitting the REST API manually. So if you run this command, it will just get all the resources in your Azure tenant. And then you can go ahead and iterate through each one, get all the information about them. And sometimes you just find plain text passwords in there that like nobody's talked about before, that sort of thing. Some really quick defensive considerations, high level things. Use managed identities wherever possible, get out of using run as counts. Like we talked about earlier, they would have saved people from that hybrid worker bug. Don't store clear text passwords in the services. It's hard, but managed identities are the fix for that. And then think of your Azure tenant in graphs. Andy Robbins talks about this a lot with Azure Hound. And I really do think it's the best way to think about it, because if you have an automation account with global admin, then all the contributors to this automation account are global admin. And like we saw, you can get some really weird situations in Azure with weird permissions on weird resources. And finally, regularly audit access and revoke it when not needed. If you have an automation account that no longer needs access to this subscription, then go ahead and revoke that. Just good practice. And these are a few resources if you want to learn more about Azure security. Like I mentioned, Andy Robbins, Carl Fossin, Lena Lau, and Jake Carnes. And these are a few blogs. So SpectreOps and NetSPI, Inverse Codes, and the AZSec blog. If you want to get up to date on Azure research, you can get pretty up to date just through these resources. And that's all I have. Thank you so much for attending. If there's any questions, you can ask them now, or you can find me afterwards.